Today we discuss chapter 8. In this chapter, we discuss summation of series and expansions of series. We discuss summation of trigonometric series based on four important series. First one is geometric progression. Geometric progression. The second one is binomial theorem. Binomial theorem. Third one is exponential theorem. And the last we have logarithmic series. Okay, these are the four chief series by which we sum the series and expand the series. So the first one by mean geometric progression, we mean that in geometric progression we need to revise the formula of GP, that is A plus AR plus AR square plus etc. all the way up to AR raised to n minus 1. So this is a first n terms of a GP. So the sum is nothing but A times 1 minus R raised to n divided by 1 minus R if R is not equal to 1. In the case when R is equal to 1, this is A plus n terms. So that will give n times A if R is equal to 1. So this is the sum of first n terms of GP. If mod R is less than 1, we have A plus AR square plus etc. gives as R tends to as n tends to infinity, this R raised to n tends to 0. So this becomes A by 1 minus R for R not equal to 1. A by 1 minus R. In second by mean binomial theorem. By binomial theorem, we meant that we mean 1 plus x raised to alpha is equal to 1 plus alpha times x plus alpha times alpha minus 1 divided by 1 into 2 times x square plus etc. So this is the binomial theorem. If alpha is a positive integer, then this contains only a finite number of terms. Otherwise, it contains infinitely many terms. So that is what we call binomial theorem. In third, we use the expansion of this exponential theorem. We use the expansion of e to the power x. For any complex x, you can write this is 1 plus x by 1 factorial plus x square by 2 factorial, etc. As a consequence, you can get other series from this exponential series. That is one of the exponential series is cosine series. So we are using the same series. We can define cos x. Cos x is e raised to ix, e raised to minus ix divided by 2. Similar fashion, you can define sin x. Sin x is e raised to ix minus e raised to minus ix divided by 2i, and finally the hyperbolic functions, sine or cos hx. This is defined as e raised to x plus e raised to minus x divided by 2. We can write these series as, we already discussed this cos x and sin x. Then I will write this cos hx here, that is 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial plus etc. The only difference between this cos hx and cos x, here we have all the terms are positive. In this we can get alternative plus and minus due to the presence of this I. So these are the series we need to remember in the exponential case. At last we have logarithmic series. By logarithmic series we mean that uh, log of 1 minus x 1 plus x equal to 1, sorry, x minus x square by 2, there is no factorial here, plus x cube by 3 minus etc. This is what we meant by this logarithmic series. So using these series we will expand the series, and we will expand terms, and we will sum up the infinite series.